Okay guys, let's take a look at today's lesson. We're going to be looking at implicit differentiation day 1. First, I would like to go through and explain what explicit or implicit defined functions are. That's kind of the basis for our lesson for today. So we've been dealing with explicitly defined functions basically for years. These are the types. These are explicitly defined where you would have a variable that's been solved for, and you only have one other variable on the other side. Basically, you get two variables. They're explicitly defined. And so these are the typical ones. We've been working with derivatives and graphing and that kind of thing. What we're going to do today is we're going to kind of open it up. We're not going to just work with explicitly defined functions. We're also going to look at implicitly defined functions. And these are examples of implicitly defined functions. Notice that they have a combination of x's and y's in them. And they could actually even have more than two variables. It doesn't have to be just x's and y's. We could add other variables as well. Some students are quite disturbed by that and really want to solve for a variable so that it would be an explicit defined function. And you can sometimes you can solve for one of them, but really the effort that it would take to say solve this for x really wouldn't be worth what you would get, because you're going to come up with a comparable derivative anyway. So what we're going to do is we're going to learn how to take derivatives of implicitly defined functions. All right, so that's our goal for today. And what I like to do is write out steps. So I have 3 steps written out on how you would do that. And so step 1 is where, first of all, we just leave it like it is. We don't move stuff around. We don't move things left and right. We just leave it like it is, and we differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. Now, that probably doesn't make any sense right now, but once we go through it, hopefully it will make sense. And so that's the first step. The second step is we will collect the terms with a dy dx on one side of the equation. I like to refer to this as tagging the term. We tag it with a dy dx, and as we go through, I'll explain when we would do that. And our last step would be to solve for dy dx. So we're going to get an expression or equation. It's going to say dy dx equals stuff, like x's and y's over there, instead of just x's. So we will get an implicitly defined derivative. All right, so I'm starting out with really a fairly straightforward, kind of easy problem, so that I can demonstrate the technique to you so you can understand what it's all about. So first, we're asked to find an equation of a tangent to the circle at 3, 4. So what do we need to write an equation of a tangent line? We need a point and a slope, right? We have our point, so that's great. We have our point, but we don't have a slope. And so what we're going to do is we're going to take the derivative of this equation of a circle, and so we can find our slope. All right. So we're going to do this with respect to x. So the derivative of x squared would be 2x. Now, we don't normally tag 2x, but let me explain if we did what it would look like. The derivative of x with respect to x. The top of the fraction is the variable that we're taking the derivative of. Derivative of x with respect to x. The bottom of the fraction is what we're taking the derivative with respect to. And so you can see why we really don't ever write that. Dx over dx, that's just 1. So we normally don't write that, but that's what tagging it means. I'm saying which variable that I took the derivative of with respect to which variable. So the second piece, so the derivative of y squared would be 2y. Which variable did we take the derivative of? Y. So it's going to be dy, and we took it with respect to x, because that's what this technique does. That's the norm, is to take it with respect to x. And then the derivative of 25 would be 0. Okay, so we've just completed step 1. We've differentiated both sides of the equation with respect to x. We treated y as a differentiable function of x. All right, step 2 is collect the terms with dy dx on one side of the equation. And so we basically just have one term in this example. It's kind of nice. So we have 2y dy dx equals, and I'm going to move, that's just a 1, I'm going to not write that again. I'm going to move the 2x over. So that's step 2, collect the terms with dy dx on one side. The last step is to solve for dy dx. So what we're going to do is we're actually going to get this by itself. In order to do that, we would divide by 2y. And so we would have dy dx equals negative x over y. Now we have an equation of a derivative that has both x and y in it. So unlike the previous ones where we could just substitute an x in to get our slope, we're actually going to have both coordinates of the point to be able to get the slope. And if they don't give us the y coordinate, what would we do? Yeah, we would just solve for it, right? We substitute back into the original, get our y value, then we would substitute into our derivative and get our slope. Okay, so it's actually 2 values that we need now instead of just 1. So if I want to take the derivative, we're going to take the value at the point 3, 4, and that would give me negative 3/4. So to write my equation of my tangent, we would do y minus y1 equals m times x minus x1. And we got it. Okay? So that's a real basic implicit differentiation. I started with a basic one so you could see what it was all about. All right, are there any questions on that one? Okay, we have one more. Well, let's go to that one. This one is going to be a little bit more fun. I really like this one. This is fun. So let's talk about what we're going to do before we do it. Let's take a look at the left side. All right, hopefully we recognize that's going to require the chain rule. The outside function would be sine, and the inside function would be x plus y. Okay? On the right side, that's going to involve the product rule, right? Because f would be y squared and g would be cosine. All right, so let's start work on that. So our first task, according to those steps that I did on the other page, was to go ahead and take the derivatives of both sides with respect to x. All right. Now when we take the derivative of sine, remember it's the outside function. What do we do to the inside part? Do we do anything to it on the first round? We don't, right? We just copy paste. So I'm not going to be tagging anything here. I'm just going to, the derivative of sine is cosine, copy paste the inside. Okay? That's the first round. I did the outside. Now we're going to focus on the inside. And we've got to multiply by the derivative of x plus y. Well, the derivative of x is 1, and the derivative of y is 1 dy dx, because I just took the derivative of a y. So dy dx, close. And so that's the left side. Okay? All right, let's look at the right side. On the right side, we're going to have to use the product rule. So fg plus fg, first things first, second things second. All right, so our first y squared, the derivative of y squared, is going to be 2y dy dx. One of the most common errors that students make is forgetting to tag the y's. It's the most common error, so please be careful. Then I copy paste the second thing, plus I copy down the first thing. Now, do I need to tag y squared? No. Did I take the derivative of it just then? No, I just copied and pasted. So don't go crazy and start tagging everything that has a y in it. You only want to tag the parts that you actually taken the derivative of. And we didn't do that with the y squared. We just copied and pasted. But the derivative of cosine, we would do that. That's negative sine x. Okay, so we actually completed step 1. We took the derivative with respect to x of the whole thing. So next, what we're going to do is we're supposed to get the dy dx terms on one side. Well, I think we can see this one pretty clearly. This one is a dy dx term. But this little guy is trapped inside there. Yes, we're going to need to release him from those brackets. So we're going to have to distribute. I know. Woohoo! So let's do it. So cosine x plus y times 1 is cosine x plus y plus cosine x plus y times dy dx equals, and then I'm just going to reorder this over here. Usually we put the tag at the end, so I'm going to write it as 2y cosine x dy dx minus y squared sine x. Okay, just a little bit of cleanup there on the right. Okay, so now we can move the dy dx's to one side. It really does not matter which side you go to. I decided to move the cosine, this guy right here, I decided to move him right. But if you move the other way, you would have the exact same answer I do. It's just every one of your signs would be opposite. Wherever I had a plus, you would have a minus, and that's fine. There's nothing wrong with that. You can go to either side. It's your choice. I'm going to go ahead and move it over here. So on this side, I would have cosine x plus y squared sine x equals 2y cosine x dy dx minus cosine x plus y dy dx. Now I'm writing out every step just because I want you to be sure you understand what I'm doing. Certainly as you get more familiar with this, you'll be able to, skip steps, but I'm just writing everything out so you can see it. So I need to isolate the dy dx ideas. Factor it out, right? Factor it out. So we factor out the dy dx. And didn't do anything to the other side. And so our last step would be to simply divide by this gigantic thing right here. So let's do that. So we have dy dx equals cosine x plus y squared sine x all over 2y cosine x minus cosine x plus y. And then we look at it and we say, okay, let's see if we can simplify it. I know you're going to be very upset to learn. There's really nothing we can do to simplify it. I know. Such a sad day. We can't factor out anything and cancel it. I mean, there's really nothing that we can do that will make it shrink. So this is our actual answer. Now I have one more thing that I need to go over that the students in earlier classes were having trouble with. And I want to make sure that we understand. So what they were having trouble with is taking the derivative of sine y. So let me explain two ways to think about it. And whichever way you prefer, that's the way you need to stick with. For me, I just think of sine y as one entity. Notice it just has a y. It doesn't have like an x plus y or anything crazy. So I think of that as derivative of that is just cosine y dy dx. Okay, that disturbs some students. Some students don't really like that. So let me tell you another way to think about it. You can actually think about it as a chain if you wanted to. And you would basically be taking the derivative of the outside. The derivative of sine is cosine. We copy paste the inside. And then we take the derivative of the inside. And the derivative of y is dy dx. So you can see that it really doesn't matter which way you think about it. You're going to come out with the same answer. I just kind of want you to figure out one way that works for you and stick with it. Whether you think of chaining it or, you think of it the way that I'm thinking of it. However that works for you, that's what we need to stick with. Okay? Questions? All right.